So, if you look on the pictures at the top of your page, well, does anyone know who can tell me what? So remember, a polygon is, or a definition, you have to compare and differentiate and then test and all that kind of stuff. So, who can give me a definition of a polygon? Give me a good definition of a polygon. Yes. Sorry, I forget everyone's name. Go ahead. Yes. Person. That's period. Is that Danielle? Wait, are you reading the book? Oh, you cheater. Okay. So it is a, go ahead, read the definition. Go ahead. Okay, thank you. A closed figure in a plane formed by connecting line segments endpoint to endpoint, each segment intersecting exactly two others. So why is this thing not a polygon? Yeah, and it has to be made up out of what? Segments, and those things aren't segments. Why is this thing not a polygon? That looks like that.
Those two line segments stick down.
Yeah, they don't, because they have to be connected endpoint to endpoint and all that kind of stuff. So why is this thing not a? Why is this not a polygon? Yeah, because it says, I think it says intersecting exactly two others, right, by that definition. See, for me, I always thought a polygon was a, that's when your parrot doesn't get enough for lunch, so he flies away.
Oh, he's gone.
Your parrot doesn't get enough for lunch, so he flies away. That's a polygon. Polygon. Yeah. Okay. All right. So we know the definition of a polygon, and then if I could find my notes, there's my notes. You have lots. I'm going to try to draw a polygon with my. I have a polygon tool over here somewhere. Over here. I'm going to just kind of draw some random polygon. Let's see if this works. Let's see what happens if I connect that. Oh, that's pretty good. Okay. So when you name a polygon, this you label these things A, B, C, D, and E, and these things have a name. These are called vertices. One vertex. So these are one vertex, many vertices. Okay, vertices. So A, B, C, D, and E are vertices. When you call a polygon, you can name it by any of its vertices, and you name it in order. Okay, so by its consecutive vertices. So this would be polygon A, B, C, D, E. But you wouldn't have to name it that. You could go backwards. You could go backwards and you could call it B, A, B, D, C. Right? You could start here and go this way. Or you could start here and go this way. What you can't do is skip vertices. You can't go A, B, B, E like that. So you have to name a polygon in the order of its consecutive vertices. What does consecutive mean?
In a row.
In a row, right after each other. Okay? So these things, this and all of those things, those obviously are called the sides of a polygon. Now, they classify some names of polygons, and that's in your book, so you could see them. But a polygon with three sides is called a what? I bet you know what it is. 3 sides. What does that say? 3 sides is called a triangle. Wow, you guys are good. Triangle. 4 sides is called what? A quadrilateral. That's why if you have a Audi Quattro or something like that, got four-wheel drive, you know, or quadra traction, or I'm gonna go have lunch in the quad because it has four sides to it. Quadrilateral. Sorry, I ran out of room. 5 sides, you know. Pentagon. 6 sides is, there's one of those in Washington, D.C. 6 sides called a hexagon. 7, it says, is called a H-E-P, heptagon. Heptagon. 8 sides, octagon, which is also known as what it looks like an octagon in real life.
Stop.
Very good. Stop sign. Yep. 9 sides. They just call that a nonagon, don't they, in your book? Is that what they say?
Yeah.
Nonagon. 10 sides
Star.
is called a decagon. Decagon. 11 sides, for some reason, is called an undecagon. Do you have to memorize all these? Probably not. 12 sides. Is that a dodecagon? Is that right? Did I get that right?
Yeah.
See, you've been teaching long enough. You learn that stuff, okay? And I'm not sure what comes after that. Okay, dodecagon.
What about the N?
And N, so if you have like something with 18 sides or something like that, you'd call that just an 18gon or something like that, okay? Like that. So after 12 sides, they don't give it specific names, they just call it a something gon. Huh? So, you know what a diagonal of a polygon. Here's a diagonal of a polygon. Let's take the arrows off the end. Let's change the color. Here's a diagonal of a polygon. There's another diagonal of a polygon. There's another diagonal. Are there more? Hey, look, it makes something cool, doesn't it? Where did I go here? Over here. It's kind of fun. Makes a little star inside, doesn't it? Okay? So, a diagonal, which I just drew, is diagonal, a segment that connects, in a polygon that connects two non-consecutive, meaning not right after each other, non-consecutive vertices. That's what diagonal of a polygon. Okay? Sorry, but we got lots of definitions and stuff like that to learn. All right. Not too much more. That connects two non-consecutive vertices. Congruent polygons. So let's go back. Congruent polygons. The definition of that is that all.
Exact same size.
Okay, in layman's words, you could say it's the exact same size and shape. Well, just kind of in plain terms, size and shape. More of a geometric definition, what they would want you to say is that all, I wanted to change colors, all corresponding angles and sides are congruent. So, for example, let's try a simple shape. Let's try something that looks like, you guys probably already know what this is called. You know what that's called? That looks like a trapezoid, right? And then I'm going to draw one. Instead of trying to draw another one, I'm going to take this one. I'm going to edit it. Watch me go. Okay. I'm going to go to. Can I do this? No. I'm going to do this. Edit. Copy. Edit. Paste. And then I'm going to take it and move it over here. I'm going to turn it. Can I turn it? Where do I turn it? Here. Okay, so now, suppose I tell you that polygon A, B, C, D, we'll label this one A, B, C, D, is congruent to, and I gotta be kind of clever here, W, X, Y, Z. Okay? And say W, X, Y, and Z. So from this congruent statement, you should be able to draw the parts or write down the parts that are congruent. So side AB, according to this statement, must go with side what? The AB has to go with WX over here. Not just based on the picture, but based on the congruent statement. Okay? BC goes with where? BC has to go with XY over here. And I would put like 3 marks or something. CD over here, I'll just put 1 mark there, would have to go with YZ, right? CD with YZ. And then AD over here, AD would have to go with WZ over here. Whoops, I should have put 4 marks there. Now I'll put 4 marks there. Okay, so from the congruent statement, you can tell which pieces line up. Corresponding, that means those parts line up. Okay, so it means, so which, according to this congruent statement, angle C, without even looking at the picture, angle C would have to be congruent to what angle? Angle C would have to go with angle Y, and so on. Angle B would have to go with angle X, and so on and so on. You get that? Yes? So based on the congruent statement, you can assume that all the pieces and all the sides are congruent. So if I took this and lined it up on top of the other one, they would be congruent. Okay? If you see, sometimes you see something that, a double-edged arrow, okay? Just to show you, because you'll run into this sometimes, and it comes up in this chapter. Anyone know what that means? It means it's true in both directions, okay? And in words, it means if and only if. So if you see this symbol, or if you see if and only if, it means it's true in both directions. So for example, if 2 polygons are congruent, their corresponding angles and sides are congruent. Okay? Going backwards, if a polygon has angles and sides that are congruent, what has to be true about those polygons? If the sides and the angles are congruent, what type of polygons are those? They're congruent polygons. Okay, so the definition of congruent polygons, if congruents are polygons, then this is true. Okay? If this is true, then this is true. So it works in both directions. Get that? That's what if and only if means. Just a couple more things, and then you can do some work for it. Okay? Next things. Uh-oh. It froze on me in the last class and it was bad. What else do I have for you? Equiangular. Equiangular. Equiangular polygons. Anyone know what equiangular polygons are?
Have the same angles.
Very good. That's it. All angles are congruent. So I can draw a picture of an equiangular polygon. Watch this. Okay. Where's my shape tool? Here's the shape tool. There's one. Let's find another shape tool. Are those two polygons equiangular? Yes.
Yeah.
Even though they're not, sides aren't the same, they all have 490-degree angles, right? You could have ones that are, all the angles appear to be the same. So those ones are equiangular. Equilateral polygon. Equiangular, angles congruent. We'll just say all angles are congruent. Equilateral. Equilateral. Who knows what equilateral means? If you're playing football and you throw a lateral, where do you throw it? Throw it in front of you? Where do you throw it? Behind you or to the side, right? Where are your lats?
Come on, Johnson, you know this.
Where are your lats? These are your lats. Didn't you know that? These are your lats. Who's a swimmer? Any swim team people? Yeah. That's where you develop your lats, right? You're doing butterfly and stuff like that, doing pull-ups, you know. You do the lat thing. That's your sides, right? So equilateral means equal sides. Equal or congruent sides. Can I have a figure that is equilateral without being equiangular? Can anyone think of one? Equilateral. How about one of these things? Let's see if I could draw one. Maybe I have one on my toolbox. Do I have one on my toolbox? No. I bet I could draw one. Equilateral without being equiangular. What do you call that shape? I bet you know. Rhombuses are, we'll learn about quadrilaterals on Friday, I think. But rhombuses, right, they have 4 equal sides, but they don't have to have the same angle. But if something is both equilateral, if it's equilateral and equiangular, equilateral and equiangular, angular, not time to go yet. You call that regular, a regular polygon. How do you spell that? Regular polygon. Okay? So for example, a regular polygon could look like it could be a square. It could be a regular pentagon. Could I make a regular, right? All angles. That's a regular pentagon if all the sides and all the angles. So if they say regular, it means the sides and the angles are congruent. Don't I have a hexagon in this thing? There must be more. Is this a regular polygon? Is this regular? This star shape is kind of cool. Is it regular? Are all the angles and all the sides congruent? No, it's kind of regular, but this angle and this angle are the same, but the little ones are not all the same. So this one is not. Oh, look. Okay, so those aren't regular. Okay, so a regular hexagon, a regular square, a triangle. That is, what do you call that kind of triangle? Equilateral triangle. Let's see if I have one of these in here. No equilateral triangles. It must. What's this do? Oh. Whoa! Where did that come from? What's this? Makes it oval. What does this do? Holy cow! I'm finding all these things that I've been looking for. All these, where'd it go? Hexagon. I want this. Try hexagon. Oh, be that way. I don't care. That's weird. That's really weird. Oh well, I'll figure that out. But if I did draw a regular hexagon like this thing, it won't do it. But if I did, it would be better. Okay, that's all I'm going to say for now. You can begin this. There's actually 2 assignments today because I want to get through 2 things. But this one is just kind of naming stuff. And it's just, I think it is page 56, 1 through 33 out. Okay? Page 56, 1 through 33 on. And then I'll let you work on that for about 15 minutes. And then I'll talk about the types of triangles for a few minutes. And then we'll go to the computer lab just like the last 10 or 15 minutes of period. Okay? And let's see. Stop. Stop.